Okay guys, so in the first video we learned how to communicate data between the sender and the receiver. In the second video we were able to print that on an LCD, and on the third video we reviewed the ESP8266 Wi-Fi module and how it is able to work in two different modes, as a standalone MCU or through the middleman MCU. And in this case we are going to take that ESP module and actually use it to post data to the internet. So let's go ahead and look at this ESP8266 and how to actually use it, in our case, to store our data on the cloud. In this case, we're going to use a website called Thingspeak.com. Alright guys, so the cloud. Let's post some data to the internet. Thingspeak.com, you can go ahead and sign up. Signing up is actually a little bit quirky, not complicated, quirky. So you go to thingspeak.com and there's this form that you fill out, and it asks you if you want to link it to a MathWorks account if you have one, which I don't, so I used my personal email address at Yahoo. And then it supposedly sent me a verify account email. It took a while to get there, so be patient. Once you get it, you click on the link and it brings you back to the internet where you can create your user ID. The first time I did this, it actually did not bring me to a password field. It brought me directly into, as you can see, this user form that they want to know about, what you're going to be using it for, etc., and directly to the my channel. But then the second time I did it, it did ask me to create a password. So just be aware of, it's a little bit quirky. Okay, so make sure you're signed in, click on new channel, give the channel a name. In this case, because I'm still dealing with the warehouse, I'm going to go ahead and name it Warehouse, Coffee Warehouse actually. And we're going to be recording temperature and humidity at first only. So we're going to log this at the warehouse, send it via an RF radio to the office, receive it in the UNO, and hopefully post it to the internet, not just view it on the LCD. So give your fields a name for simplicity's sake. However, that's one of the weird things. They're still actually called field 1 and field 2. So it brings you to your channel view, and as you can see, there's no data posted either for temp or humidity. You're going to need an API key in order to write to it, and in this case there it was, but create your own obviously. And as you can see up here, this is the format for writing data. So I used it, and there it is. It has written 2 data points for me, and that's exactly what we're going to be doing from our ESP. Okay, so let's get the wiring out of the way. Remember, this is the way to talk via AT commands. RX to RX, TX to TX, CHPD and 3.3 go to VCC, and ground always goes to ground. Okay. Now remember, this is for AT commands, and eventually we're going to look at using the ESP directly, because it is indeed more stable and more beneficial to do that. But I want to cover this as well. Okay, so remember, we're going to be sending AT commands from the microcontroller. We are going to be using the middleman first. So we're focusing on the scenario on the right, and we're going to be using commands such as AT plus CIP, whatever. And we'll go through these when we get to the coding part. So let's go ahead and move over to the wiring first. So we're going to make a complete post to the web. This is the wiring that I'm going to be using in this case. We're using software serial to use RX as 11 and TX as 10. Ground to ground, VCC and CHPD, and GPIO and GPIO 0 and 2 are not going to be used in this case. So let's go ahead and jump straight onto the code. Now be aware that you may use 5 volts for VCC, but it's up to your own risk. 3.3 is recommended. Okay, so this is our code. As you can see, we use software serial and we define RX and TX as 10 and 11. We define a few strings for variables, and you should replace your SSID, your password, and your API key from Thingspeak in this case. We're using the host and the port that we that we can see there on line 7 and 8, and the field, we're going to use field number 1. And then we define a Boolean and the software serial ESP8266. In the setup, we go ahead and we send a few commands just to get the module kickstarted and ready to connect. And then in the loop, as you can see, we're actually getting the sensor data. And then we're going to create a string that's going to be used to post that HTTP GET request to the internet using the AT commands that follow, and finally print the data to the serial monitor and CIP close to close the connection on line 30. All right. To in this case, get sensor data, we're just going to create a random number from 0 to 1,000. We're not going to actually use a sensor in this case. We're just testing the connection and data posting function. For the send command, this is a helper function, and you can go ahead and copy this as is. It's basically just something to tell us if the command was successful or not. If it failed, it's going to write fail. If it works, then it's going to go ahead and write OYI. So, all right. This is the send command function, and for now, let's just understand it the way it is, and we will go ahead and review the AT commands later. So let's go ahead and see what the results look like on the serial monitor. And if this works, we're gold, because all we have to do is use get sensor data with real sensor data. Okay, so here is our serial monitor, and as you can see, we have been able to post data to the internet, and you can see OYs and sometimes some fails in there. So we are able to post the data using this string that you can see. It's also going to be available in the description, but you can see here, this is the format, or the string format, that a Thingspeak API uses to receive data, whether it's from your browser or from this ESP module using the MCU intermediary. All right, so okay, so we know how to post data, so let's go ahead and post some real data. So I'll see you in the next video, and I urge you to like, share, and subscribe. See ya.